every day. Check pressure, temperature and flow rate pipeline to make sure everything stays normal and stable. Collect values such as pressure, temperature and flow rate at a regular interval to track how the parameter change over time. Every month, look the trend of pressure and flow over time so you can see slow change that might be problem later. Every 3 months, flush the line to clean the inside and check the difference in pressure before and after flushing.
For the internal pipeline, we use ultrasonic testing to check the wall thickness and corrosion in the internal pipeline after receive the abnormal data pressure from the preventive maintenance. The data of the ultrasonic testing, we will give it to the corrective maintenance to do the next maintenance.
Firstly, we do the inspection on internal pipeline, which is we check the level thickness. If the level below from minimum allowable thickness, we need to repair the pipeline by cutting and replace with the new pipeline. If the level above from minimum allowable thickness, we just continue the internal pipeline. This is example of pipeline cutting process using pipe beveling machine. This is example of process coating for internal pipeline.
Okay, for the third is about the internal pipeline. This is high priority area. We can detect a corrosion at the pipeline. So, for our next step is perform a detailed root cause analysis, or we call RCA, for the pipeline, and proceed with a material upgrade to more resistant grade of piping to make it efficient and good quality.
For daily general observation, they look at the outside of the pipe for the leaking or physical damage like dent or the crack. Every week, the maintenance team check the insulation on the outside of the pipeline to check any crack or missing. Every month, visual inspection at the pipe surface like check for the rust, peeling paint or other sign of wear. Every 6 months, inspect for the coating check on the pipe for the thickness by using holiday test. For yearly, look at the outer surface of the pipe for any sign of corrosion, rust or discoloration. Check for the pitting, flaky metal or brown or red rust spot that shows surface metal.
After we get the information peeling coating from the preventive maintenance, it might have the temperature variation at the pipeline. So, we use the thermal imaging to detect the temperature at the pipeline. By using the thermal imaging, we can observe the temperature at the pipeline. If there are any variety of temperature at the pipeline, there might be corrosion at the pipeline.
Second inspection is external pipeline, which is we check the corrosion at pipeline. To fix this problem, we need to clean the external pipeline surface and re-coating it. Here the example of process coating external pipeline.
First, the external pipeline. So we can see the insulation design. We observe that the need improvement, also the drain, to prevent moisture build up and external wear. We will modify the design to more better water flow and protection.
For once a week, check for looseness by making sure the bolt and connection are tight. Every month, we do a visual inspection to look for rust, crack or any visible damage on hanger and supply. Any damage, defect or abnormal condition, write a clear remark in the checklist to describe the issue to tell what exactly is wrong.
When the preventive maintenance give the information about the crack and loose bolt at the support and hanger, it might related to the vibration. At here, we use the vibration analyzer to check the amplitude and the frequency of the support and hanger, and then remark the result on the checklist.
Third inspection is we check the position, wear or damage at hanger and support. To fix this problem, we need to re-alignment and replace with new hanger and support if damaged. Here the example of process re-alignment and change the hanger and support.
About the hanger and support. To maintain the structure integrity of the system, we look at the stress distribution. We found that the current setup needs a support redesign to better handle the weight and vibration of the pipe during operation. Okay, so we see the support is the hanger, is the U-bolt type. So I think it's not mesh for the display, so we need to redesign, and also we might first.
It's wrong. Every day, check the leak at the flange by looking for the drips, smell, so we can find problem earlier. Once a week, check the flange bolt to make sure they are not loose, because loose bolts can cause leak or joint failure. Every month, do the visual inspection to see if the flange are aligned correctly and there are no visible issues. Every 3 months, perform a torque check on the flange bolt using the correct torque value so the gasket seal evenly and prevent leak. Write a short remark to record the result of the torque.
For the flange, we use the thermal trend and visual inspection to check the flange after receive the information about leak at the flange. By using this method, we are collect the data of the temperature and pressure at the flange. When the flange have the leak, it can cause the pressure drop slowly during the operation. And when the gasket has degradation, it can cause the temperature rise at the flange.
Fourth inspection is we check the leakage at flange area. If they have leakage at flange, we need to replace the new gasket. Here the example of process replacement gasket.
For the last one in the checklist proactive maintenance is about the flange and gasket. We are looking the gasket type and the element to prevent leaking. Okay, so inside is gasket. So we will upgrade the gasket material and ensure the element is perfectly calibrated during in the next maintenance window. So the flange also we need to check and must to see if a good condition or not condition. Also we remark it.